Hi Chem Gang, in this video I'll be going over the work through for Skill Builder 11.10, which involves partial pressure, total pressure, and percent composition. First of all, in section 11.9 in the text we learned that too much of a good thing can actually be a bad thing. For instance, scuba divers breathe pressurized air, and when a scuba diver dives to about 30 meters, the increased pressure of oxygen causes a higher density of oxygen molecules in the lungs. Now we need oxygen in order for our cells to work properly, but too much oxygen in our body tissues causes something called oxygen toxicity. And when we have too much oxygen available in our tissues, the symptoms of oxygen toxicity are muscle twitching, tunnel vision, and convulsions. And if you are a scuba diver that is experiencing tunnel vision and convulsions, it could cause drowning, which is fatal for a scuba diver. So it's a really important thing to understand the composition of the pressurized air that scuba divers are breathing. So in this example, we have a diver breathing the heliox mixture with an oxygen composition of 5%. So I'm going to write that as my percent of oxygen is equal to 5.0%. And the diver wants to adjust the total pressure so that the partial pressure of the oxygen is 0.21 atmospheres. What must the total pressure be? So we're looking for total pressure. And the formula that we're going to use is the partial pressure of the component gas is going to be equal to its percent composition of that gas times the total pressure. So this is the formula that we're going to be using. Now, our percent pressure, we're going to do it as a decimal because we don't use percentages. So 5% divided by 100 is going to give us 0.05. Our atmospheres are fine. So now I can go ahead and plug this in. If I know that my partial pressure of oxygen is 0.21 atmospheres, that's going to be equal to my percent composition of oxygen, which is 0.05, times my total pressure, and that's what I'm trying to find. So to isolate my total pressure, I'm going to divide both sides by 0.05 in order to cancel that out. And then I will get my total pressure is going to be 0.21 atmospheres divided by 0.05 equals 4.2 atmospheres, which is my total pressure.